Okay, so today's going swimmingly. I'm just about ready to call everything off on grounds of bad planetary alignment or something. But anyway, God bless technology, making my life simpler since like 1980, whatever. Okay, let's get on with it. Tens and nines complement. So tens and nines complement is really, or complements in general, is really just a way to subtract by adding the complement is really what this is. So uh, it should, in some instances, help you avoid long strings of carrying when you have to carry all the way over. That said, in base 10, actually in anything other than binary, I'm not sure how worth it is as far as time goes. It's often just easier to do the work. In binary, it's really easy because you just flip everything that's a one becomes a zero, and everything that's a zero becomes a one. So it's just, and you're done, and then you add, and boom, you're out, and it's easy. So it's really nice. In tens, you're still kind of doing some work. Um, so let's look at that. The book does a fairly good job of telling you how to do this. And after we look at how to do this, we're going to look at why it works. So that's kind of what this is adding to the situation. Okay, this video is adding to things. All right. So let's assume for a moment that you have to subtract 5,186 from 6,024. You can see that I'm going to have to carry all the way over here from the 6 because all of these numbers are larger than these. So I'm going to have to go all the way back to the 6 to work this. And that's just a lot of carrying. But let's go ahead and do that so we come up with our number. I can't pull 6 from 4, so I borrow 10 from here, giving me 14 here. That, of course, then gives me 8. I can't borrow 80 from 10, so I have to borrow, I can't subtract 80 from 10, so I have to borrow from here. I can't borrow anything in the hundreds column, so I have to borrow all the way back to the thousands. So we'll borrow 1,000 from here, making that 5,000, making this 1,000. And then pulling this, borrowing then 100 from here for making our tens column 110. I can now 80 from 110, of course, gives me 3 or 30, sorry. And then 100 from 900, of course, gives me 800. And the 1,000 zero out. Okay, so that's basically our answer. And I'll flip to the next screen where I have that sort of cleaned up. Okay, so there's our answer. Now, the tens complement, the way you do tens complement is we're going to take our subtrahend here. We're going to take the complement of the subtrahend and add it to the minuend. So first off, we have to take the complement of the subtrahend, and we're going to do that by subtracting it from an order of magnitude higher. This is a great word. It took me forever to really figure out what that word means. I got it off of Real Genius of all places, right? I had to look it up. What's an order of magnitude? Anyways, so an order of magnitude is really just, whoops, dang it, is really just a power higher of whatever base you happen to be working on. So what that really means is that we're just going to go and add 1 to the next column over. So here we're subtracting thousands, so we're going to subtract it from 10,000. If we were doing, like, say, just 186, we would subtract it from 1,000. If we were doing 86, we'd subtract it from 100. So that's just that magnitude higher. Hold on a second, please. So this, as you can see, isn't going to help our carrying any. I'm still going to end up carrying all the way out here, and I'm not going to do it. I'm just going to go ahead and 4,814 is what it works out to be. Let's see, 4,814. Now the point is the tens complement really isn't saving us any time because we're still going to end up carrying all the way back to over here. So what we can do is utilize the nines complement, which is just 1 less, and then add 1 in after the fact, and it all evens out. So the nines complement looks like this. oops, come here. Wow, let go of that. Thank you. Okay, so 9's complement looks like this, and it's easier, as you know, to subtract each of these from 9 is just really actually fairly simple. So we get 3 here, and 1 here, and of course 8 here, and 4 here, and you can see that this is just 1 less than the 10's complement. Now I can add the 1 in at this point, or I can do it after the fact, like after I finish adding this to the minuend. I could do it then like the book does. It really doesn't matter when you add the 1 back in as far as I know. But we'll do it like the book does. So we'll take this here, and so we're just going to see we've got our minuend from here. We've just taken that number here, and we've taken our 4,813 here, and we're just going to go ahead and add it for 7, 3, 8, and 10. Now the book tells you, and this is kind of what's neat about the book, it tells you to take this 1 off of here and pull it down and add it in, which it isn't really, I'm kind of mathematical as such, but functionally it makes some sort of sense, because you're really not taking 1, you're taking 10,000 and moving it over and suddenly deciding it's 1. It's like hocus pocus, boom, and now it's a 1, yay, okay. But it works. I mean, it sort of makes sense visually, I guess. So we can do that. We can take this 1 from here, move it down here, and then when we add these together, we of course get 8, 3, 8 with a 0, and we don't need that 0, but okay. So we've come up with the same number, and that's what it does. If we were to do it with the, do I have that here? Yeah. If we were to do it with the 10's complement, right? If we were to add the 1 in here, make this 4,814, then we just simply drop 10,000 off the equation. So this is 8 and 3 and 8 and 10, and then we just have 10,000 too many, so we just wipe that out because because we don't need you. But anyways, you're adding the opposite, and we'll show you why it goes over in a minute, in order to get, or adding the complement in order to get the same answer. Okay, so let's look and see how this works, and we'll look with a much easier, a much easier problem instead of this 1 out to the 4th. We'll go ahead and look. Yeah. Okay. Let's see. Okay. So here we go. We're going to take 8 minus 3. So it's much easier. And taking 8 minus 3. So what we're doing, I'm going to do this on a number line. I can't draw on this. Anyway. So okay. Oops. Really? Okay. So we're taking 8 minus 3, which it will really end up being 5. But I want to show you how this works. And it works like this. So we're going to actually, if you look at these spaces here, that is really 7. Okay, so we have 5 up to here and 2 up to the 10 is 7. So if we move this up to 10, remember this is 8, 10 is our magnitude higher. So if we move that up here and take 10 minus what our subtrahend was, I apologize, I got rid of that. Remember it was 3. Okay, that brings us down here to 7. So basically what has happened is that these spaces here, here, and here end up sort of combining together here, right? Okay, so 10 minus 3 is 7. If we add that 7 to our original 8, you can see that it blows past the magnitude higher. It blows past that 10 mark by 5. And the reason it does that is because that's what's remaining from our group. So basically, that is really kind of how tens complement works, is it simply takes this space here, combines it together, adds it to the original, which blows past 10, since we're actually filling out this whole 10 section. When we go past when we take this number, it blows past it by exactly the amount that we're lacking here, is really what tens complement is about. So I hope that makes it a bit clearer. Again, tens complement, nines complement, not terribly useful for base 10. You can see that the work, you're not really saving a lot. When we get to twos complement and ones complement with binary, that's where it's going to really show its glory. So, all right, have a great day, and we'll talk to you in class. See you.